Strong acids and weak acids are essential concepts in chemistry, particularly in understanding how acids behave in aqueous solutions. The distinction between strong and weak acids lies in their ability to dissociate and produce protons, hydrogen ions, H, when dissolved in water, which directly influences their acidity and the pH of the solution. Acids produce protons in water through a process called dissociation. When an acid is dissolved in water, it releases hydrogen ions, H, into the solution. This is because acids contain hydrogen atoms that are bonded to electronegative atoms, such as oxygen or chlorine. In water, these hydrogen atoms are released as free hydrogen ions. The dissociation process can be represented by a general equation for an acid HA as shown on the screen. Here, HA represents the acid, H is the proton, and A is the conjugate base formed after the acid donates its proton. The extent to which an acid dissociates in water determines whether it is classified as a strong acid or a weak acid. Strong acids are those that completely dissociate in water, meaning that nearly all of the acid molecules release their protons into the solution. This complete dissociation results in a high concentration of hydrogen ions, leading to a lower pH value. Examples of strong acids include hydrochloric acid, HCl, sulfuric acid, HSO, and nitric acid, HNO. When HCl is dissolved in water, it dissociates completely as shown in the formula on the screen. In contrast, weak acids only partially dissociate in water, meaning that only a fraction of the acid molecules release their protons, while the rest remain intact. This partial dissociation leads to a lower concentration of hydrogen ions in the solution, resulting in a higher pH compared to strong acids of the same concentration. Examples of weak acids include acetic acid, CHCOOH, and carbonic acid, HCO. For instance, the dissociation of acetic acid in water can be represented as shown on the screen. The double arrow indicates that the reaction is reversible and only a small proportion of acetic acid molecules dissociate at any given time. The pH of a solution is a measure of the concentration of hydrogen ions, H, present in the solution. It is calculated as the negative logarithm of the hydrogen ion concentration on the screen. Because pH is a logarithmic scale, even small changes in the hydrogen ion concentration result in significant changes in pH. A solution with a high concentration of hydrogen ions, a strong acid, will have a low pH, while a solution with a lower concentration of hydrogen ions, a weak acid, will have a higher pH. For example, a strong acid like HCl might have a pH of around 1, whereas a weak acid like acetic acid might have a pH around 4 at the same concentration. It's important not to confuse strong acids with concentrated acids. The strength of an acid refers to its ability to dissociate in water, while concentration refers to the amount of acid dissolved in a given volume of solution. A strong acid can be very dilute, meaning it has a low concentration but still completely dissociates in water. Conversely, a weak acid can be highly concentrated, meaning there is a large amount of acid present, but it still only partially dissociates in water. For instance, a dilute solution of hydrochloric acid, HCl, can still have a lower pH than a concentrated solution of acetic acid, CHCOOH, because HCl is a strong acid that fully dissociates, whereas acetic acid is a weak acid that only partially dissociates. Understanding the difference between strong and weak acids, as well as the concepts of pH and concentration, is crucial in predicting the behavior of acids in chemical reactions, industrial processes, and biological systems. Strong acids, due to their complete dissociation, are often more reactive and capable of causing more significant changes in pH, while weak acids, with their partial dissociation, play important roles in buffering and maintaining pH stability in various environments.